Welcome back, my mathematical minions and minionettes. Well, today we're going to look at wrapping it all together with quadratics. So we're going to tie everything we've done together all in. So we're going to put it in standard form. We're going to look at ax squared plus bx plus c. We're going to look at it in vertex form, a times the quantity x minus h squared plus k. And finally, intercept or factored form, where we've got a times the quantity x minus p times the quantity x minus q. So let's go ahead and let's start with the function f of x equals negative 3x squared minus 30x minus 48. Well, the first thing we should notice is this one is in standard form, okay? So we've got this one in standard form. So what do we know about standard form? Well, standard form, first of all, we can see that this one is going to be opening down, okay? It's got a maximum. It opens down. Oops, max. It opens down. How can we tell that? Well, we can look at that negative out in front, that negative 3x. That a is negative, so that tells us we have a maximum. It's opening down. Well, that 3 in the a there, it tells us it's going to be narrower, okay? It tells us that we've been stretched vertically, okay? That we've stretched it vertically, or we could say that it's been compressed horizontally. It's been squeezed in from the sides. But we can tell that from looking at that 3 out in front. And then finally, that negative 48 tells us that the y-intercept is negative 48. It crosses the y-axis at the point 0, negative 48. All right, so let's look at the next forms and let's see what we can do. So let's take this right now and let's go ahead and let's find the axis of symmetry. So axis of symmetry. Remember, this is that vertical line that splits it down the middle, that cuts it in half so that we have exact replicas on either side, so that it gives us a symmetric graph. And we're going to use x equals negative b over 2a. So first thing, we need to identify our a, b, and c. Well, a is negative 3. B is our next term. B is negative 30. And c is negative 48. So using this, that means we're going to have the negative of b. Well, b is already negative, so that means it will be positive 30 over 2 times a. Well, a is negative, so we have negative 6. So 30 divided by negative 6 is negative 5. So that means our axis of symmetry is at x equals negative 5. Remember, axis of symmetry is a line. It's a vertical line, so we always write it as x equals. All right, so the next thing is we're going to find what f of negative 5 is. So in other words, we're going to plug negative 5 in for x as we turn around and do this. And so we're going to have negative 3 times negative 5 squared minus 30 times negative 5 minus 48. So f of negative 5 equals, well, negative 5 squared, negative times a negative is a positive 25. So we've got negative 3 times 25. Okay, now we've got negative 30 times negative 5. So that means we've got a positive 150 and a minus 48 out at the end. Okay, so next step in here, when we're combining these, we've got negative 3 times 25, so negative 75. We'll go ahead and let's do 150 minus 48. So that gives us a positive 102. Now our last step, let's just finish this off. So f of negative 5 is going to equal a positive 27. So what does this tell us? That tells us that our vertex then, our vertex is at the point negative 5, 27. So we've got that one taken care of. Axis of symmetry found. We found the vertex. Let's go ahead and plug it into vertex form now. Now, in vertex form, remember, we look at this, the a comes out front, so we still know that we've got a maximum, okay? We still know that it opens up. It's still going to be narrow. It hasn't changed anything. Our a is still negative 3, but now we've got that. We know that the vertex is at the point negative 5, 27. So writing this in vertex form, it's going to be f of x equals our a, which is negative 3, times x minus, this is our h term of our vertex. Well, it's a negative 5, so we're going to be plus 5 squared, and then plus our y term. 27. So f of x equals negative 3 times the quantity x plus 5 squared plus 27. So there's vertex form. All right, one more form to go. Let's look at this again. Now let's look at putting this in intercept form or factored form. Well, the first thing we need to notice is if we look at these before we start to multiply, notice that we can factor something out. So always the first thing we look at when we're trying to factor these out is, can we pull out a GCF? Can we pull out a greatest common factor? And the answer here is absolutely. We can factor out a negative 3. So let's factor out a negative 3 and let's see what we're left with now. We now have x squared plus 10x plus 16. Okay, so if we factor that out, things get a whole lot easier. Now it also changes our a, b, and c that we're concerned with now. We look at it now, our a as far as factoring is 1, our b is 10, and our c is going to be 16. So because our leading coefficient is 1, we don't have to use our box in it. We can simply look at this and we know we're trying to find two numbers that multiply together to equal 16 that add together to equal 10. So take a second, see what you can come up with. All right, so hopefully we've come back now and you've decided, hey, the two numbers are 8 and 2 because 8 times 2 is 16, 8 plus 2 is 10, so those are our factors. That means when we write it, the factors would be x minus 8, x plus 8 and x plus 2 is what it's factored. Okay, so those are our two zeros, or help us find our zeros. So when we look at this, remember our zeros are going to be what makes each of these 0. So what would x have to be to give this a 0 here? The answer is negative 8. And what about the second one? It's a negative 2. And yes, for those bright ones that have already figured it out, you can just simply say it's the opposite of whatever's inside of the parentheses, which is the same thing we pointed out in everything else. If we've got a plus 8 inside, the 0 is at a negative 8. So let's take this back and let's write it in our intercept form. So realize, what do we know from intercept form? Well, we still know we've got a max. We can use that a and see we've got a max. We can see that it's narrow. Okay? We can see that that 3 has compressed us horizontally, that it stretched us out vertically. But the most important thing that we can see is we can see where our zeros are in this one, and we can see that our zeros are at negative 8 and negative 2. So we should be able to graph this one fairly easily. So let's go ahead and write it into intercept form, into vertex form. Remember, we factored out a negative 3. Now we have x plus 8 times x plus 2. And there we go. There's everything we need to know about these, all done without a calculator, all factored. So, time for you to take a look at one on your own. So I want you to take 4x squared plus 24x plus 27, apply what you know about this one, and see what you can come up with. See if you can identify all the important characteristics for it. What can you identify from each of the forms, transform it into the forms, and then we'll look at it.